entitled to say that is the process capable or not. If the process is not in the control status, it is not feasible, or this is not appropriate to say that if the process is capable or not. Okay, learning objectives. Investigate, analyze process capability. So that means, so we would like to satisfy the requirement designed or specified by our customer or R&D department, the research and the development department. Then, so are we really capable of producing the product that really satisfies the requirement by the customer? So actually, we need to answer this question. That's why the CP and the CPK and CPN are typically used to analyze the capability of the process owned by the company or the enterprise. Second, we're going to use the control chart histogram and probability plots. Second, understand the difference between the process capability and the process potential capability. C stands for capability. The C stands for capability, the P stands for potential. And K stands for actual. So this is in the CP and CPK. Interpret process capability ratio. So this is the ratio. We like to investigate the CPK and CPM. This, and this. It's called the process capability ratio. The process capability ratios. To understand how to conduct, analyze a measurement system, a gauge and non-R. The first one is repeatability. Repeatability and then reproducibility. So repeatability that arises from the gauge. The gauge that means that is designed to perform the metrology, to take measurements, and the reproducibility arising from the operator. Then understand to set specifications on component system involving interaction components to ensure that the overall system requirements are satisfied. So let's move on. Yeah, like this. This is process capability refers to the uniformity of the process. So apparently the variability critical to quality CPQ characteristic in the process is a measure of the uniformity of the output. So this is natural tolerance limit. upper natural tolerance limit. Typically, this is a mean and minor 3 standard deviation. So the natural or inherent variability in a CTQ at a specification time or specified time, that is instantaneous variability. Like today is January 4th. In the morning 9:30. So we take a snapshot, like we take a camera, take a snapshot, and look at the process and collect the data and draw the histogram like that. So this is the instantaneous upper natural control limit and the lower natural control limit. So this is the natural limit are defined as follows. So this is called this is like a snapshot we take at a particular timing. Then, okay, so the variability in a CTQ characteristic over time. Sometimes is that really always fixed at this distribution? No. Sometimes it is, sometimes it isn't. So we need to look at the distribution over time to supervise if the process capability is stable or not. So there are two ways to think of variability: natural tolerance limit, this upper lower, so instantaneous variability, or the CTQ over time. Okay, done. In this case, this is a mu equal 1.0, deviation 0.001. In this sense, process capability analysis may be formed without regard to the specification of the quality characteristics. So, like this. So right here is upper natural tolerance limit. This is lower natural tolerance limit. So now I draw the specification limit. Okay, let me. So I use a red pen to represent the specification limit. If the specification limit is like this, is process capable? Is process capable enough? Answer my question? Yeah, it is capable. Since this is required by the specification. However, most of the product produced is within the specification limit. Then, if the specification limit is this narrow, is process capable? No. There's a major portion that is extrapolate out of the specification limit. Then, if the specification is like this, is the process capable? Yes or no? No. Even though on the right hand side, most of the components or product produced stay within the limit. However, at the left side, there's a big portion that's going to fall out of the process, fall out of the specification limit. Then, what about this? Is this process capable? No. So, we consider the distribution, also consider the center position. What is the center of the specification limits? Get it? Get it? 听得懂吗？啊？哎，还有， 什么的？来自工系的，你知道我在干嘛？来说一下。specification limit 它不一定在中间。我刚刚有很多种状况，产品规格是谁定的？谁定的？产品规格是谁来定产品规格？班长。
生产者本身。
产品规格。
什么协会吧 ，ISO。
再来，再继续讲。停。产品规格谁定的 ？Customer 啊，你客户定的啊。还有谁定的？来，4年级的同学。产品规格除了客户可以定，还可以谁可以定 ？R&D 啊，对不对？我今天要开发这个神兽，我今天要开发这个 iPhone， 我还去问客户说你要什么样规格？不会吧？我自己定规格，我来期待客户的什么需求嘛？来 ，so 来，所以说这是我什么生产的结果，对吧？我的能力就是这样，那我要跟谁来比？跟我当初设定的规格，对不对？我这样就代表说我有没有能力生产？有啊。我这样有没有能力生产？没有啊。大部分为什么跑出规格外？我是怎样？我产出来的东西还有谁要？这样行不行？也不行啊。这边会什么跑出来？这样行不行？不行嘛。所以要考虑什么？它的 distribution， 还有它的什么？它的什么中间的位置？中间的位置会不会跟我生产中间的位置相符合？你运气好就会符合，要看你的能力好不好。所以说我们重点要是什么？假如是这样，我们希望什么？把这个 distribution 往什么右边移，中间就怎样？把中心点尽量调到什么？我的规格中心线，听懂吗？你可以调它的 distribution， 可以调它的这个中心线。来，大致。There is not. No, this is not. Okay, use a process capability data to predict how well the process will hold the tolerances. So what is the tolerances? The tolerance is defined like this. The 3 standard deviation, the mean and 3 standard, that is called the tolerances. And assistant product developer, designers, in selecting or modifying a process. So that is try to help you. So there's a feedback. Is that possible? Possible to reach the capability? Then the information of such as investigation going to be fed back to the designer. Now you need to do an adjustment or not. Second, assistant establishing an interval between the sampling or process monitoring, specify the information required for new equipment. So for the future, if you like to have a new product to be designed, then what kind of the specification should be set up? Then in order to make your manufacturing team to be manufacturable, so we call it manufacturability. So sometimes it is very difficult. That's why the concurrent engineering is need to be established. That is a communication and a conversation between R&D and the manufacturing. So if we design a perfect product, however, the manufacturing team not able to produce, so we are not capable to fulfill the implementation of this design. So that's why the designer or the R&D staff need to take the manufacturability into consideration. That is called if the product is manufacturable or not. Sometimes it is manufacturable, so you are capable. If it is not manufacturable, then it is not capable. Okay, so like this. The process may have a good potential, like this. Some reason for poor process capability. The upper is lower than. Wow, this is so wide. The customer is so generous. There's a give you so wide specification called the upper specification limit and the lower specification limit. They're so different from this. This is the upper natural tolerance limit. This is the lower natural tolerance limit. This is called tolerance. Then the upper specification limit and lower specification limit is required by customer or R&D. So, well. So it is potentially capable, right? If we move the center to the left, then the distribution, all the distribution will fall between the upper specification limit and lower specification limit. So we need to process adjustment for the process A. So this is for process A. Then how about that? B, for process, so A is for process centering. So you need to just shift to the process centering to the left in order to the most of the product output will fall within the process specification limits. So process B, the excess of process variability. So in such a case, how can we make the process manufacturable or process capable? The process B. Jimmy, right? How can you make this the process B? How? You don't know. Yeah. The curly board. How would you like to make it process capable? Have no idea, somebody? Somebody? The birdie? How would you like to make the process capable?
就是叫厂商放宽它的标准，是这个意思吗？让它那个变快。
你要求你的客户放宽标准，那你就别做生意啦！你哪有这种思维啊？
倒过来想可以。
0分，来下一位。
哎，那再给我一次机会。
Yeah, no, that Miss Zhao.
一样吗
Miss Zhao. How to make it process capable? 来 one more time.
好了，就是要求我们自己的人精准度要变高。
Yeah, of course, it does. Yeah, of course. We're going to reduce the process variance, and then it will turn out to be more quick, right? So reduce the process. So reduce the process variability. Okay, done. Here's a histogram probability plot like this. Example 8.1. 8.1. Okay, page 320. Like this. So going to, yeah, this is a bursting strength example for a 100 glass container. In terms of histogram analysis of the 100 observation, X can be estimated as 264.06, and the sample standard deviation can be evaluated to be the 32.02. So process capability would be estimated like the X bar plus and minus 3S. So this is torus limit. So this is torus limit, right? The torus limit. Then this is 264 plus a 0.0 plus and minus 3 standard deviation. The 3 times 32.02. So this is the PSI, the pounds per square inch. Pound per square inch. This is this is the matrix for the pressure. Then furthermore, the shape of the histogram implies that distribution of the bursting stress approximately normal distribution, like this. Like the bell shape, there's a center, this is the symmetric with respect to its center. So we can estimate approximately 99.33 of the bottle manufactured by the process between, this is around the 168 and 360. Between the 360 psi and 168, within this interval, which will cover approximately 99.73%, if the distribution is normally distributed. Right? So note that we can estimate the process capability independent of the specification on the bursting. So yeah, so it could be. So plotting the capability, normal probability plot. So the container. So we like to take this. So based upon that, so know that the estimated process capability, so like this, between the 360 and the 168, you approximately covered. It approximately covered the 99.73. This region we're going to compare to which? So our customer, is the product to be produced for within this region? Do you satisfy? Do you satisfy this interval or not? So make a comparison. Then, or using a probability like this. What is the center? The 50. This is normal probability plot, so you can plot the center and so if it is a normal distribution, there's if the center, the mean plus 1 sigma and minus sigma is going to cover 68%, right? So what is right tail probability? 32. There's a 32 divided by 2, right? 16. With the 32 by 2, the right tail is about 16, right? So this point going to be from negative infinity to this point is about 84%, right? 84. So this location is min, and this location is mu plus the mu plus 1 standard deviation. What about this? The mu from the negative infinity up to the center is about 0.50, right? So the difference is going to be the, okay, let me do that. So we're going to do that. The 50% is right here. Then you can find what is the center. Measure it. Yes. And we found out the 84%. The 84%, and you can find out what is the position. And this position and this position, this number, subtract this number, the standard deviation can be computed. Do you get it? One more time. The 50% is approximately corresponding to here, right? So this position can be determined. Then 84%, the 84% is right here, right? Correspondingly, you can determine what is the score of in the original scale. What is the correspond? So that position corresponding to the 84%. Then you got the position corresponding to 84% subtracted the 50%. And this number, the difference between these two numbers, will be the standard deviation. Get it? Just make a note. 班长了解了吧 ？Okay, thank you. Hello, guys. Take your hands out. Make the note. It's not that cold. Today is a little bit warm. Look at your class leader. Only take one teacher. Look at him. This is a real man. This is a real man. 我们上次圣诞装除了我的课，还有什么课传啊？没啦，那你就专门弄我就对啦。
可以这么说。
Any questions so far? No question. Yeah. Okay. 吃啥是啊？吃啥？
地瓜。
哦，可以。It's quite healthy, very good. Healthy. 真的吗？他家种地瓜，真的、哦。
他家田很大。
哎，什么时候我们全班去弄一下？哎，你家在哪里？苗栗。
新竹。
你家真的有地瓜田？
是啊。
还有地瓜叶。
产给啊。
你们真的是大牌吗？还是？
没有，我爸种开心的。
种开心的。
开心农场。
OK，
还有开心水族箱。
OK，A.3 我们现在班剧也可以去你家那个胡韩族，然后烤那个烤叫什么土窑鸡。
可以啊。
哎，你家真的有庭院啊？
有啊。
真的吗？你家是农场？你家是农场吗？还是那个？
不是啊，
算庄园，
就是乡下人会有的家。
哦，真的吗？你家是2层楼还是3层楼还是？3
合院。
2层楼。
2层楼。
很
不错哎。
前面有庭院可以玩，然后后面有
池塘。
有鱼池。
有鱼池。
还有养鱼。
有没有养鸭、养鸡那些？
有啊。
哦，太好了 ！This is place I expecting for a long time. Yeah, I really love it. Yeah, I love it. So 在山上吗？宝山山上？
没有，在
琼林。
在琼林，就是竹北旁边。
哦，OK。
贫富差距很大。
No, it's not that. No, it's no different. I went in Taiwan, from the Taipei to Pingdong only 400 kilometers, right? So that's not that. The Taiwan is so small. Okay, 8.3. 8.3, we're going to move to page 323. Okay, using the interpretation of CP, this is called the potential capability. Let's look at the equation 8.4. It is frequently convenient to have a simple, quantitative way to express the process capability. One way to do so is through the process capability ratio, that's called a PCR. The first one is CP first introduced in chapter 6. So we'd like to look at this, CP. CP. So the denominator is a 6 sigma. It's comparing to the natural tolerance limit. The numerator is the specification limit. So if the ratio is equal to 1, what is the meaning of the ratio equal to 1? Gentlemen? So that is the tolerance limit equal to the specification limit. So that means we barely make the process capable, like this. If the process is this wide, and then specification exactly the same, we barely make it, right? However, we barely make it. The CP is close to 1.0 around. This is around 1.0. However, how dare you if the process is shift a little bit now, it's not capable. It's not capable anymore. Am I right? Yeah, of course. The process, so actually, sometimes it is on the target. However, the tolerance limit going to move around sometime over time. They're moving around. Why? The process is not that stable. So typically, if the process CP1 is greater than 1.0, the process may be really capable. Right? Like this. Like this. Wow, we're potentially really capable. However, once in a while, it turned out to be this way. Now, the process needs to be adjusted. Right? Then if the specification limit like this, no, we are no longer capable anymore. So typically, you're going to ask me, what is a threshold? What is the threshold? Typically, we expect the CP to be. What is the minimum value for the CP? What do you think, Tim? Yeah, of course, there's a minimum. If you are an engineer or you are a supervisor, what kind of value are you expecting for it? Okay, take a break. You're going to answer me this question like that.